Exploratory data analysis is an important skill for anyone building a career in AI or data analytics. In this video, we are going to build a data analytics project where we will analyze 500,000 sales transactions from UK-based online retailer. We will do trend analysis, customer segmentation through RFM analysis, customer churn analysis, and so on. We will also analyze 32 million records using FireDucks library to showcase how you can do large-scale data analysis. We will do all of this in Google Colab by using their AI assistant so that we get a feeling of new way of coding in this AI era. Along with technical skills, you are going to learn few important domain skills in retail industry. Let's get started. Here is the dataset that we are going to use, which will have 500,000 records. The columns are invoice number, stock code, which is the product ID, description, quantity, invoice date, unit price, customer ID, and so on. We'll perform all typical steps right from data loading, data cleaning. We'll also create some new features, and then we'll do visualization and exploratory data analysis to generate the insights. Later on, we are going to analyze 32 million records. We will synthetically create new records out of our original dataset, and I will show you how using FireDucks library can speed up your analysis. Let's open Google Colab by running colab.research.google.com. You can log in using your Google email ID. You can use a local Jupyter notebook as well, but running in Google Colab will allow you to run FireDucks later on seamlessly. That is the reason we are using this. So here, let's open this and click on new notebook. Now new notebook is being created. Now here you have this particular folder, okay, and it is connecting right now to your hardware basically. So you're running this in cloud, which is Google Cloud, and you will get different options for your hardware. We'll select that, but you can see that there is a sample data folder which doesn't have anything. So we're going to get that online retail analysis file from internet, and we are going to use UCI machine learning repository. So this is the data set we are using. You can see 500,000 records here, and let's go to the notebook now and select change runtime type. And I'm going to use V28 TPU. Okay, so that is little better configuration. If you're not seeing this option by any chance, then just run with whatever you have here. Let's install some important libraries first. So we are going to need this OpenPyXL. So when you run it like this, in your local environment, it will install that library. Usually when you're running this on your local computer, you can run the same command, right? Pip install, etc. But when you're running this in cloud environment, you don't have this library installed initially. So in the cell, Jupyter Notebook cell, you will type this exclamation mark and then run this, okay? Also, you can click on this code now to write the new code. So here, I will import Pandas and Matplotlib. Now, when we do large-scale data analysis, we are going to use FireDucks. And FireDucks is a Pandas compatible API. So our code will remain same. You will only change one line at the top. So I will show you that whenever there is an appropriate time. But for now, let's get that data. Okay. So online retail.zip. This is the file we are going to get using wget command. Wget is a unique command which will get the zip file from cloud location. Okay, so let me just run it here. So see, it is running and it is downloading that 31 megabyte file. And when you look at here, you will see this file here. Okay, now you're going to unzip it. To unzip, you will just run this particular command. Okay, and you can see that now you have this file. All right, let's load that into a data frame now. pd.readXL. And you can already see AI assistant at work. It recognized this file and it auto-completed that. And I'm going to call it df1 because at different stages I will have df2, df3, these kind of data frames. So I want to keep things separate. That's why I'm calling it df1. And then let's print few records. I will also explicitly specify the type of certain columns like invoice number, stock code, etc. Because otherwise it will keep it as a default Python object type. And I want some optimization here. So that's why I'm specifying these types explicitly. It is 500,000 records, folks. So it's gonna take some time. It has loaded this particular data frame. And you can also go to this interactive table view, or you can do suggest charts. Okay, so these are all the features of Google Colab. Now let's look at the shape. Okay, so df1 shape, and we have 500,000 records. I will also check the data types of different columns, and you can see that invoice number is string, this is string, quantity is integer, and so on. Now we will do some data cleaning, which is handling missing values. Okay, so let's create this text cell, and here I'm going to add a header called data cleaning, handle missing values. Okay, and then create a code cell where I will say df1 is null dot sum. Now what this will do is, if you know Pandas, it will show you number of NA records per column. So here I have 1454 descriptions as empty. Okay, so we need to see what's going on. So let's look at some of the records which have null description. So how do you do that? So you will say df1 dot description is null or is NA. Okay, and see, I'm seeing all these records where description is NA. Okay, now let me do this. df1 dot stock code is equal to this. So I want to check if there are other records which have same stock code but valid description, right? So you can see that. So these are, by the way, normal online retail transactions. So a person, let's say customer ID, whatever, they bought this stock ID. Okay, stock ID means item, butter, bread, peanuts, whatever is that item. They bought this. This is their invoice number, and they bought it in this much quantity, and this is the date, and this is the unit price. Okay, unit price is invalid, so we'll do cleaning for that later on. But here you can see that for stock code 22139, there are records which have valid description. So when you look at it, naturally you will think that retro sport tea set ceramic 11 piece, maybe this is the right description, correct? Because see, NA is invalid, then Amazon looks like invalid. So whatever you have in majority of the records, okay, that seems to be the right description. So how about we use this logic for any stock code? If description is null, look at other records with same stock code, and then whichever is the description that appears most frequently, we will use that to replace this NA. So here, this NA you can replace with retrospect, etc. This NA you can replace with retrospect, etc. I mean, Amazon also you should replace. Okay, so in all the records where you have stock code this, the description should be this. Okay, so how do you do it? So see, when you do description on this particular data frame, this is a data frame, right? And on that, when you do mode, you might know about mode. Mode is the most frequently occurring value, and that value is this. Okay, so we are going to use this to replace the NA values. Now we can do this particular operation where we get stock code and description, 2 columns, and we just get the value counts. Okay, so let's get the value count for all of these. And what you will notice is the way this function works is it will sort the records such that the one which has highest count will appear at the top. So for this stock code, you have this much count of this description. And that is like doing mode, okay? Most frequently occurring value. Now in this particular data frame, the index is this. So I would like to reset the index. So reset index so that you see normal 0, 1, 2, 3 index, right? Okay. And let's call this most frequent. So this is the data frame which contains the most frequent description for these items. Okay. So now, by the way, now look at this recommendation from AI assistant. Okay, so view recommended plots. When you do this, it's going to give you all these recommended plots, and you can just click on it and generate it. This is all using Gemini model from Google. All right, let's move on to the next step now. So now I'm curious, in most frequent data frame, if I look at this particular stock code, how many records am I going to find? Okay, so let's run that. See, so this is how it works. So when we created that data frame and when we did value counts for a given stock code, it will have multiple records and the count, a stock code and description, by the way, because one stock code apparently has multiple descriptions. And see, these are looks like wrong values, error. Okay, so the logic that we will use is, in this particular sub data frame, we will take a first record, which is head, correct? Like head, this. And for that stock code, this will be the valid description. So let's perform group by, because see, this is just one stock code. We can't do this for all the stock code, right? So the right way is to group by this particular data frame by stock code and then dot head 1. Okay, so that is my most frequent. Let's see what we get. All right, perfect. So now what I have is stock code and its valid description. Most likely this should be a valid description based on our logic. Now we can merge our original data frame, which is df1. Okay, df1, we can merge it with most frequent on stock code. Again, there was an autocomplete by AI assistant, so you can see how it is making me productive. And that will be your df2. Okay, so df2.head. And before I do this, see what's going to happen is in df1, there is a description column. In df2 also, in most frequent also, there is a description column. So I just want to differentiate these two. So what I will say is most frequent dot columns is equal to these three. Okay, so only change I have made is I changed this from description to frequent description. Okay, so let's do the merge operation. And now you can see that you have stock code. This is the original description and this is the frequent description. So hopefully this should have all your errors fixed. So now for those rows where description is null, I will replace that with frequent description. You know what? I'm having a second thought. I would probably replace all the description values with this. Why? Because we saw one of these values, right, where it was Amazon. Like Amazon is not a valid description, right? So let me just show you. I think it was here. So when we are looking at this, see this is not a valid description. So I want to replace NA, but I want to replace this also with whatever is the most frequently occurring operation. So here I will just say df2 description is equal to df2 frequent description. Okay, and then we'll just drop that other column. Okay, so it looks like this. Now let's do that. Is now dot sum. So now there are only 112 description items. It's possible that there are some stock codes where you don't have description at all. So which is fine. So now we are going to drop those items. Okay, so df2 dot drop any subset is equal to description, in place is equal to true. Okay, so whichever record has a description as null, it's going to drop that. And in places, it will just modify the original data frame. So now I don't have any NA value in my description column. Now I have customer ID column where I have some null values. And when I talk to my business manager, they're like, it's okay. You can ignore those because for the sales transactions, you care about your invoice, your stock code, your price and items and so on. Maybe they forgot to register a customer, which is fine. All right. Now in DF2, I'm going to drop the extra columns, which is these two, right? Frequent description and count. So let's drop that. All right. My data frame looks much more cleaner now. Okay. Now let me run df2 describe. And what I notice here is in quantity, I have minimum as minus. See, you can't have negative quantity. When you sell something, see, for refund, you will have different type of transactions. So negative quantity sounds like an error. When I again talk to my business manager, they're saying it's an error. Unit price, negative again. You can't have negative unit price. So we are going to handle all these negative values. Okay, so let's see what exactly is going on. So quantity, df2 quantity is less than 0. Okay, negative quantity, negative. We'll probably drop that. This could be refunds, I believe. But, again, so this is situational. When you're working in a company, you talk to your business manager and kind of perform the best action. Business manager or whoever is owning this database, there will be data engineers or software engineering team that owns this database. You can ask them if this is an error. And many times there are errors in enterprise databases. So we are assuming that this is an error and we are going to clean it up. Also, let's look at the unit price. So when unit price is less than 0, okay, there are just 2 records. So looks like we can remove it, but see, if you look at the description, adjusted bad debt. So it could be a valid record, but for our analysis, it's okay. I mean, we can get rid of this. And customer ID is also NaN, so we can drop it. So I'm going to create a new data frame where I will say df2 dot unit price is greater than 0 and df2 dot quantity is greater than 0. Only keep these records. So you have to put this into brackets and then df3 dot describe. Okay. See, now we do not see all those negative values. Now you're seeing some very big values. So for quantity, your 75 percentile is 10, right? So the range varies from 1 to 10. So 75% of customers, they're ordering items in the quantity of 10. Now, is this a valid value? 80995. We don't know. So let me just do some further exploration. So quantity dot, so you can do quantile and let's find out which value is your 99 percentile. 99 percentile means 99% of all the records contains quantity 100 or less. Okay. So 99% record, all the records, most of the time customers are entering quantity 100 or less. If you look at 99, say again, it is this number. So let's check what's going on. So df3 dot quantity greater than, let's say 1500, and I get all these records. So here quantity is this. See, you can show these records to your business manager and ask them whether these looks like valid records. They can be valid, right? You might have received some wholesale order where the quantity can be very huge. Let's say somebody is arranging an event, they're having wedding or something. They come to your store, they're ordering things in bulk, or some other retailer came, they ordered things in bulk. So looking at these records, they do not look like an error because see, there are like valid unit price, customer, etc. So we're going to leave this thing as it is. You talk to your business manager, your database owners, and you figured, okay, this is okay. In case if you want to remove the outliers, you can use quantile method. So remove anything which has quantity greater than, let's say this, which is 99.99% quantile. You can also use IQR or 3 standard deviation. to remove these outliers. But in our case, we're going to assume these are valid, legitimate numbers, so we will not touch them. We will now do some feature engineering to create new columns for our analysis purpose. See, when you have quantity and unit price, the natural question you will have is, what is my total sales amount, which is quantity multiplied by unit price. Okay, so let's calculate that. I will create a new data frame. So df3.copy. Sometimes if you don't do it, you will get some error. So let's just create this and say it is reading my mind. So it is saying df4 total price is equal to quantity into unit price. So this AI assistant can look at the context of your current code and other files and give you suggestion, or it can generate the code. See, if you say generate, you can say generate new column for total sales using quantity and unit price. Folks, this is the new way of coding in the era of AI. Okay, so you have to use this AI assistant. Okay, so see here it realized that you already have this one, so it kind of renamed it. Okay, so it is so smart actually. Let's see if I did not have that. Okay, so let's say I did not have this. So when I hit enter, see total sales is equal to this. So you can use this assistant to perform fast coding basically, but you have to remember that you don't become dumb in that process. You have to look at the code, try to understand it, because it is going to impair our cognitive abilities. Using AI assistant too much will affect, it's like using GPS for direction all the time. Although you're going on a known route, while you're using GPS, it will impair your thinking abilities, your memory, and so on. So use this with caution. Okay, it can be dangerous. Anyways, now I have total sales. So see, if you multiply this with this, then 15.30 pound, that is my total sales for invoice number this. And same invoice has different stock code. So invoice this and stock code this is the total sales. Now I would like to do some trend analysis where I want to perform analysis of monthly sales, how they're going up and down. For that, I need a month, right? If I want to do monthly sales analysis, I need a month column. And here what I have is invoice date. So invoice date is a date object. So if you look at df4.info, let's look at the data type of that particular column. Okay. So that is your date time. I want to extract month from that. And I want to create this new column called month and invoice date. So if you do dt.month, okay, it will create, because this is a date time object, and you can do .dt.month. See, you see now the month. So this is 12, this is 12. If you just randomly sample few records, hopefully you'll see different months. See, this is February, right? February. This is November, 11 months. All right, so my feature engineering is complete for now. We can do more feature engineering later on. So let's add a text cell saying that now we are going to do our visualization and EDA. And in that, the first thing I will do is plot monthly sales. Okay, so 1, 2, 3, 4. Plot monthly sales. All right. Now, the benefit of adding all these headers, folks, is like if you look at this table of contents, so you can easily navigate. Okay, data cleaning code is here. Feature engineering is here. Visualization and EDA, monthly sales, right? So that's why I do it. And I will just add one more hash to kind of make it like a subsection within visualization, right? So visualization C, and that helps you navigate better. So df4 dot group by. So when you do, folks, when you do group by month, okay, it's gonna group all the sales from a given month, and then in that group, you want to look at total sales column and then do sum on top of it. Okay, so here in this group, look at total sales and then do sum on top of it. And what you get is this. Let's call this monthly sales. Okay, so this is my monthly sales. Now say it is giving me the code already. AI is giving me the code, and I'm just tempted to use this. So we are going to plot a bar chart for monthly sales. Okay, so let's do this. And bar chart looks like this. You can also plot a line chart. Okay, so let's plot a line chart, and marker is O, and then I will do plot.grid, plt.grid. All right, now you can draw some insights from this monthly sales. Initially, the sales are lower, but in the last few months, which is 10, 11, and 12, the sales are picking up. Now, there could be many reasons for this. It's a holiday season, first of all, in UK, like Christmas time. So that could be one reason where sales are picking up. This concept is also called a hockey curve, where after a certain point, the shape looks like a hockey. The sales are jumping, and it could be because that the store wants to get rid of some inventory, and maybe the sales representatives have some bonuses. This is online retailer, by the way, but still, let's say if this was a brick and mortar store, the sales rep will have some bonuses associated with their sales performance. So they want to fulfill their quota for yearly sales, and they want to get rid of things at the end of the year. You notice the same thing in car sales also. Recently, I wanted to buy a car, and someone suggested that buy before December, because these sales representatives from car companies will have this quota, and they want to just get rid of that inventory before the year ends. Okay, so there are a variety of reasons, but the trend is very obvious, which is at the end of the year, the sales are jumping. Now we have 1 year worth of data. If we had more data, we would have noticed this trend year over year. So let's say in last 5 years, every time if I'm seeing sales are up in last 2 months, then it tells you something, right? It tells you something about holiday season, bonuses, etc. So what you do usually in your notebook is you create a text cell and you note down your insights like this. So when you share this notebook with somebody, they can consume these insights and make sense out of your visualization. Okay, now we are going to do the second step, which is top 5 countries. See, it will show you this robot. I'm not robot pop-up. Top 5 countries by sales. Okay, so I'm gonna use AI here. We will say plot horizontal bar chart for top 5 countries by total sales. Okay, now it is going to look at your previous code and realize that, see, group by country, then you look at total sales and then you sum and sort those values and take first 5. So if you look at this top 5 countries here, top 5 countries, see, this is what I get. Basically, UK is your number 1 country. See these many cells, Netherlands are in the descending order. And then you can plot a horizontal bar chart. See here. So this way you get another insight. Now, what is also useful is to plot percentage. I will once again use the AI assistant and say plot same chart, but this time use percentage and show percentage on the bar. Okay, so see, it's actually simple code. Instead of grouping by country, you're still grouping by country, but you are using the top 5 countries sum. Okay, now this is the thing with AI assistant. They won't be perfect. They'll be making a mistake. And here, it is taking sum of only top 5 countries. I want to take sum of all the countries. I want to know the percentage contribution as a whole. Okay, so this is a wrong code and we need to fix. So how do you fix it? So you can just say country wise sales where you will not take, you will do this. So this is all the sales, and then total sales is country-wise sales dot sum, and percentage contribution is this. Okay, so let me just remove this, and when I run this code, see, UK is contributing 84.6% maximum. Netherlands is 2.7, 2.7, and so on. Now, it depends on how you want to interpret it. Usually, one interpretation that people will make is you have too much dependency on one country for your sales. So let's say if something happens to that country, some geopolitical crisis occurs, or some taxes and rules changes, then your business will be impacted in an adverse way. So usually if you can go global, see, in case of online shopping, you can go global. It's better to diversify into other countries so that you can reduce the risk. Now, other way of looking at it is okay, we have expertise in UK market, we want to focus on it. So it's okay even if you don't diversify. But in that case, you want to give best service to your customers because you have too much dependency on one country. Similarly, we will do product-wise sales, okay? So same thing, instead of country, you are doing product-wise sale. And for product-wise sale, you're using stock code, okay? Now, when you look at all this stock code, see, the maximum sales is from this stock code DOT. Now, what is it exactly? So if I want to know what exactly is this DOT, I can do this df4 dot stock code is equal to DOT, right? Is equal to DOT, and that is .com postage. So similarly, you can run the for loop for top 5 products. So top 5 products is basically your, where is my top 5 products? Yes, here. So for top 5 products, if I print the description, see, these are my top 5 selling products. Then I can plot the same chart, but use percentage. So now we will use percentage, and you can see that we don't have too much dependency on one product because there are many products that we have. We have so many unique products, okay? So that's why the first selling item DOT is only 1.9%, only 2% of total product sales. We need to first get the maximum date out of that invoice date, okay? So DF, okay, which one I have? I think DF4, right? So DF4 invoice date dot max. So this is the maximum invoice date. We cannot take current date because this data is cut off at some point. So I want to take this maximum date, and then I want to do ed dot time delta to add just one day on top of it, and let's call it current date. So this was 9 December 2011. Current date should be 10 December, okay? So see, this is the 10 December date. Now we will group by our data frame by customer ID, correct? Because this is the analysis on customer. So we are going to group by customer ID. And on that group by object, we will perform aggregate operation, and we will create few columns. So these are the 3 columns we'll create. Invoice date. So invoice date, you take basically the invoice date and then you subtract it from current date. Okay, so current date is let's say 10 December. And then why you're doing x.max? Because you might have multiple records for one customer. So let's say for one customer, you have 5 records. Out of that, take the maximum based on invoice date and then figure out the difference. So essentially, this will tell you the recency value for each customer. So each customer has multiple records. It will take the most recent date. It will subtract it from current date and give you the days, number of days. Invoice number, you look at invoice number and you get the count. Okay. So based on that count, you can get the frequency and total sales. When you do sum, it will give you the total monetary value. And you will call that RFM, right? And then RFM, I'm going to call the columns these 3. Okay, so RFM.head. It will take sometime, I think. Okay, I'll just call it current date. And see, this is the RFM analysis table. For customer ID, my recency is 326, which means, so let me just verify. Okay, you should always verify. So in my DF4 data frame, I want to look at customer ID. Let's say this has 2 recency. Okay, so let me check this one. So what I'm noticing here is for this customer, 1, 2, 3, 4, 7, recency is 2, right? So let's look at the date. So if you look at all these dates, they bought it on 7 December and today is 10 December. So 10 and 7, they bought before 2 days, right? Like, so there is like one difference here. And if you look at this particular customer, which is 4/6, they bought it 326 days before. So see January. So January 18 to December 10, that is around 326 days. And then frequency. So it is telling you the frequency monetary value. So let's look at the monetary value here. Okay. So again, I will do 7. And on this particular data frame, when you do total sales sum, okay, so total sales and then sum, you get 4310. See? All right. Now let's cut our data into quantiles. So when you divide these numbers into quantiles, you can make sense out of that data. Okay. So I'm just going to copy paste some code here to save the time. Essentially, you are using Pandas qcut function. So qcut function, what it will do is it will take a column and it will cut that into 4 quartiles. Okay, 4 quartiles. And these are the labels 4, 3, 2, 1. Now we are starting from reverse because the most recent customer will get higher score. Okay, so we are doing some kind of scoring where if the customer has bought very recently, it's a valuable customer for you, because if you're running any marketing campaign, you can target them because they are more likely to buy your product because they bought something recently, correct? So you are giving them higher score. Okay, so let me just actually show you so that you get an idea. See, essentially for this customer, this was recency, frequency and monetary. So they belong to this tier. Essentially, you are dividing these customers into tiers. So if the recency is 326 is like big number, so their R segment is 1. But if recency is 2, see, their tier is higher if recency is low. Okay. For frequency, it's basically, see, if they're buying at a higher frequency, like see, this guy has a higher frequency. So again, tier is higher. And monetary value will also get some kind of tier. And your RFM score is the sum of all these 3. So when you sum these up, and if the RFM score is high, these are valuable customers. These customers are having either high recency, frequency, monetary, or combination of that. Okay. So this RFM score will help you serve these customers better. So in this, let's sort the values by RFM score. And see, these are your valuable customers. These are your gold customers, basically. They're having very high value of RFM score, and you want to serve them in a special way because they give you a lot of revenue and a lot of business. Now let's discuss a very important topic, which is RFM analysis. RFM stands for recency, frequency, and monetary. What it means is this. Let's say you have this kind of table and today's date is December 12. Now you want to know certain things about your customer and their purchase behavior. For example, this customer C009, okay? How many days have passed till they made their last purchase, okay? So this is December 12. C009 made their last purchase when? December 3, December 7. December 7 is the latest date, right? So between 7 and 12, there is 5-day difference. So for this customer, the recency value is 5. For this particular customer, they made their last purchase on November 12 and today is December 12. So approximately their recency value is 30. Okay. So you create this kind of table where you have customers, their recency, their frequency. Frequency means how many transactions they are making. So if you look at just this small table, C009 made 2 transactions, right? Like this and this. So frequency 2. Whereas this person bought only once. Okay, so let me just change this in color. So this is 2, this is 1. What is monetary value? So you take quantity into unit price. So we have total sales, right? So total sales for this invoice and this invoice. So you sum it up and you put it here. So this is the total sales that is generated through this customer for the company. Okay. And this is useful because some customers might have less frequency, but when they come, they do huge buying. So their monetary value might be higher. When a customer has high frequency, let's say the customer is coming and shopping from your store, online store frequently, let's say they buy once every week, it means they are a loyal customer. If they want to buy something, they come to you. I am a loyal customer of Amazon. Whenever I want to buy something, I just go to Amazon.com. I have an app, I just order it. And I have this Prime subscription, so the order comes the next day. So if Amazon is doing my analysis, they will find my frequency value to be high. But monetary value, I'm a little bit minimalistic person. I don't buy expensive items. So my monetary value still might be lower. A recency will be higher for me because I always buy from Amazon. Okay. So you can use all these 3 parameters to do variety of analysis. And what people usually do is they create this table. See, right now this table has only 2 records. Actually, there could be 200,000 records like this. So you will create quantiles. Quantiles means for recency value, you will divide the recency value into, let's say, 4 quantiles. Okay. So let's say your recency value varies from 2 to, let's say, 450 days. So you will create, for your distribution of customers, you will create 4 quantiles. Okay. So quantile 1, quantile 2, quantile 3, and quantile 4. Let's say quantile 1 has customers ranging from 2 recency value to 30. Then quantile 2 might have 30 to, let's say, 45. Quantile 3 might be 45 to, let's say, 120. And Q4 might be 120 to 450, right? So you can do this kind of a quantile division and you can perform further analysis on top of it. And you can do the same thing with frequency and monetary. So let's move to our Jupyter notebook. It's okay if you don't understand these things. These are actually very easy. So once we write code, you will understand. The last piece of analysis we are going to do is customer churn analysis. And to save the time for recording, I will just show you the code because it is really simple. For customer churn analysis, you can use this recency value. Very simple. So if recency value is higher, the customer is likely to churn. Churn means they're going to leave you. Because if they have not been buying with you, it is likely they have already left you or they're about to leave you. So when you find that out, you want to reach out to them. You want to give them some promotional offers, send them some birthday coupons, etc. so that they come back to you for buying. Okay. Now you can use RFM table, but I just use original data frame to group by customer ID and then took the invoice date and maximum. Okay. So maximum invoice date. And then I found the recency value. So I found recency value in a different way. You can use RFM table as well. Okay. For each customer, these are the recency values. Okay. And you will have this 90-day threshold. So in this table, whichever customer have more than 90-day value, you will classify them as churned customer. Okay. So see, this customer did not buy in last 326 days. This customer did not buy in last, or they bought the last item before 310 days. Okay. And you can plot their distribution. So this is just a histogram and 90 days, your, let's say, boundary. 90 days, like if customer has not bought for more than 90 days, then I would say, okay, customer have already churned. They have left us. So this is the boundary. And you will see that people who have not bought in, let's say, 150 days, the total number of customers are around 80, right? So you can look at the Y value. So these are like number of customers, okay, in that bucket. It's a histogram, folks. I hope you know about histograms. Okay, so that histogram will give you a lot of insights, and it will help you retain your customers or target those customers who have already left with some offer so that they can come back. Folks, now comes the exciting part of analyzing 32 million rows. For this, we are going to use FireDucks library. They are also a sponsor for this video. It is a compiler accelerated data frame library, fully compatible with Pandas API. So if you have Pandas code, you can just change one line of code at the top and that's it. Yeah, this will work, okay? You can import FireDucks.pandas as PD. It is as simple as that. And remaining API remains the same. This has a lot of advantages. It is sustainable and economical. Okay, it is multi-threaded, JIT compiled, fully compatible with Pandas, and it is a CPU compiler accelerated library. So I have created two different notebooks. So I created one notebook which I'm going to share. Check the video description below. But other than that, we have created two different notebooks. Okay, so let me just show you. So in one notebook, it's the same code, folks. Okay, see Pandas, we are using Pandas here. But I added one line, which is I multiplied the data frame with 60. It was 5 million and now it is close to 32 million. See, 32 million. So you just concatenate it. Basically, you concatenate the same data frame 60 times, horizontally 60 times. You concatenate and you get 32 million records. And I ran that entire notebook on my cloud V28 TPU. And using Pandas, it took 167 seconds. Okay, so I have these timestamps. I hope you know how to do profiling in Python, right? You take the timestamp at the beginning. Very simple stuff, folks. Timestamp at the end. And it took 167 seconds. Then I used FireDucks. Okay, so in FireDucks, what you have to do is you say pip install FireDucks, then this other library, and I added this one line. So either you can do import FireDucks.pandas as PD, or you just add this special line and remaining code is same. See, import pandas as PD and so on. And here too, you have concatenated the data frame 60 times, okay, and created this 32 million records. So when I run this, see, FireDucks is taking 90 seconds, whereas Pandas is taking 167 seconds. Folks, this is huge performance improvement. So folks, going from 167 seconds to 90 seconds seems like little less than 2x performance improvement. But let me show you something very interesting. If I go to FireDucks notebook and add this particular line, you will see that read Excel alone is taking 45 seconds out of 90 seconds that is taken by FireDucks notebook. And for read Excel, we are using fallback logic. Fallback means that FireDucks doesn't implement that feature. Okay, FireDucks doesn't have performance improvements for read Excel. And for that, it is falling back to Pandas. So in reality, the expensive operation of reading Excel file is performed in Pandas. It is not performed using FireDucks optimization. So if you look at the actual performance gain, if all the operations were done by FireDucks, it will be much higher. And you can refer to their benchmarks page. Here they compared Pandas with DuckDB, Polars, and FireDucks. And excluding I/O, FireDucks gives you 78x improvement. Including I/O, these are the improvements. See, 32x, 38x, and so on. So just to summarize, some of the functions that we see in this notebook, they are using fallback. And when they fall back, they are using Pandas, not using FireDucks internal optimizations. Therefore, the actual performance gain by FireDucks is much higher. As a user, you don't have to worry about what is implemented by FireDucks or not. You just write code using Pandas API. FireDucks is fully compatible with Pandas. So you just use Pandas API and everything will work smoothly. The FireDucks teams will implement these kind of fallbacks based on user requests. So if you go on their GitHub page, they will take all these requests, and in their weekly releases, they will implement some of these features. So if you're working on a data set which has millions and millions of records, FireDucks is recommended because the code is same, fully compatible with Pandas API, but this gives you a boosted performance. And I really like this environmental part because you are contributing less to the CO2 emissions. You are running code in optimized way. So they have done some internal optimizations. You can check their website to know more about what kind of optimizations are done. I will include all the links, but please check these two notebooks. Okay. We just concatenated this 60 times just to show you performance aspect. You cannot look at the actual numbers for the analysis, right? Because these numbers will be a little bit skewed because we just duplicated records. But my whole point is to show you the performance benefit of FireDucks, okay? So folks, pip install FireDucks, please use it. I think FireDucks is not available as of this recording on Windows, but on Google Colab, you can install, you can run it. If you have Linux system, you can obviously run it, okay? So if you're using Pandas, try to replace it with FireDucks and see if you're getting performance benefits. FireDucks works better on large scale dataset. When your dataset is huge, it will give you a good performance improvement. All right, that's it, folks. If you have any questions, there is a comment box below. This project will give you a lot of experience on how to do EDA, which can be used for data analytics as well as for AI. Because remember, before building AI model, you'll have to do exploratory data analysis, data cleaning, generate some insights, all of that. So this project will be useful even if you're targeting AI career. I hope you liked this video. If you did, just share your feedback in the comments or via thumbs up icon, and I wish you all the best.